what goes on here today, and then I'll post this afterward in Blackboard. All right, so I'm going to present to your screens, and let me pull this over. Okay, so what I'm trying to present right now is Autocad. So let's see if you can see Autocad up there. So can somebody who's broadcasting, are you seeing AutoCAD right now? Seeing two drawings. Okay, so we're seeing a front view and a side view. All right, so we've got, here we've got a simple example of a multi-view drawing, right? And let me let somebody else in. So the thing that we think about whenever we're dimensioning is that this part has a bunch of features. And if you break it down into features, the diameter of that hole, for example, that's a feature, right? And the sides of these planes here, each of those would be a feature. This chamfer that we have right there would be a feature. And so when I dimension, or when I teach people to dimension, I recommend that you break it down into the features. Let's see, somebody's broadcasting some audio. Can y'all check and see? There we go. I think it went quiet. All right, so you want to break this down into features. Yeah, it might have been Eric. And then kind of dimension it that way. Now, AutoCAD has a bunch of great tools for dimensioning. So dimensioning itself is pretty easy. It's just doing it correctly that's hard. So AutoCAD would allow you to put a bunch of dimensions on real fast that would be wrong. So you can also up your error rate in AutoCAD as well. So what I'm going to do is just show you how we might put some dimensions on for this part right here. One of the first things we would want to know is where's the center of this hole located at? So last week we opened up the dimension toolbar. And so this is the dimension toolbar over here, and I hope you have it open. It'll actually help you a lot. So if you don't have it open, the way to do it is you go up to Tools, you go to Toolbars, you go to AutoCAD. You don't have to pick on those, but then you come down here and you pick on Dimension to open that up. So I have Dimension and Draw and Modify and Object Snap turned on, and that's what you're seeing over here. Now, if you don't have that open and you want to find Dimension tools, they're in this panel right here, which is called the Annotation panel. And most of your tools right up here on that button right there, if you click on the down arrow, you can find a lot of the tools that we use, like radius and diameter and linear and stuff like that. But you have all of your tools over here on the toolbar. So you actually have access to more tools, I think, on the toolbar. All right, so like I said, we're going to figure out where the location of the center of this hole is. And so what I would start with is what's called a linear dimension. So that's this top tool right here, or you could go over here and pick on it right there. So after you pick on it, it says specify your first extension line. And that would be the edge that the designer gave you, that the designer said, let's locate this circle from this edge right here. So if you were trying to figure out where to start, you would look at the sketch. So let's say the designer started from this corner right here, and then we would come over and we would want to tell the person reading our drawing where the center of this hole is. Now, where we want to pick on that hole is right here at the quadrant, which would be down there. Then we want to move down here and pick. Now, what I have showing on the screen is actually a tolerance. And so what a tolerance is it's an allowable error that we give the manufacturer, and it's the designer who calculates what this tolerance would be. And so what we're seeing here is 1.00 plus or minus 0.01, which means that the distance from this edge to the center of the hole could fall anywhere between 0.99 and 1.01, and this part would pass inspection. All right, so a tolerance is just a little bit of an allowable error that we give manufacturers. And like I said, I'll get more into this next week, but I just want to show you that there's really no perfect dimension. There's always a little bit of tolerance given, but the manufacturer has to make the part within that tolerance or you don't have to buy the part. Or if it's an in-house part, you might get another machinist if they can't manufacture their parts within tolerance. All right, so the reason why this tolerance is showing and the reason why this dimension looks like it looks is because it has a bunch of characteristics that are defined by a dimension style. And so the very bottom tool on the dimension toolbar that you have right here, I'm going to click on that. And so right now the dimension style that I'm using is called toleranced, right? And that's why I've got this tolerance showing, because I have settings in this. But I'm going to go up, I'm going to change my style and go to something called ASME small radii. Now I've already made this one, and so don't worry about the name. We'll get into the name a little bit more later. So I'm going to set that one current, and then I'm going to close this, and I'm going to pick right here and delete that out. And I'm going to go back to my linear tool again, and I'm going to go from this corner to this quadrant and move my mouse down. And there's a normal dimension right there with no tolerance showing. All right, now, so you're wondering, well, where would the manufacturer get the tolerance for that? Well, this is a 1.00, so it's a two-place precision right here, right? So if we go to our layout and we get into paper space and we look right here in the title block, we can see that anything that is at two-place precision has a tolerance of plus or minus, in this case, 0.02. So any dimension labeled to two decimal places would have a plus or minus 0.02. The designer tells us what to put right here. Now that dimension I showed you a minute ago had a plus or minus 0.01, and so that's just because I hadn't reconciled it with what was on the title block here. But anyway, the point of that is that the number of decimal places that you take your dimensions to has an effect on the tolerance a lot of times. So you have to be careful. And so if the designer gives you two-place tolerances, you need to be sure that you're putting two-place dimensions on there. And if the designer gives you a three-place dimension, you need to go to three places, because that would affect the tolerance that's applied to that. If you don't get your tolerancing right, then you change the design intention of the designer, and we call what the designer wants design intent. You don't want to change design intent. That's a good way to get fired, okay? So it's just as simple as that. You change design intent, you get in hot water. So I'm going to go back to this right here. All right, so we've placed that first dimension, and now I'm going to go and place another dimension using linear again. I'm going to go from this corner to this corner, and I'm just going to move that second one down like that. All right, so there's the location of this edge relative to this edge over here, so we have the width of our part. Now, I'm going to put another linear dimension, and this time I'm going to go from this corner, and I'm going to go to that quadrant right there, and I'm going to move over to the right like this and pick. Okay, so now I know where the center of that hole is located. So this dimension here and this dimension here are actually called location dimensions. They tell us where the center is located at. Another thing I need to know about this circle right here, this hole, is what's its diameter. And so I'm going to go up here in my annotation. I'm going to pick on this down arrow, and I'm going to use the diameter dimensioning tool. It's right here, diameter, and it says select the arc or circle, and I'm going to pick right there, and I'm going to move out here like this and pick. And what that does is it puts the diameter for that circle on as a leader. Okay, so now I know where the center of the hole is located. I know what its diameter is, and I know how wide this part is. There are a few things I don't know about the part, like what's the size of this chamfer right up here. So if I used a linear dimension again, and I went from this corner to this corner, and I went right up into there and picked, and did that again from this corner to this corner, would move this out into here. All right, now sometimes you can pick on a dimension and drag the text right up there in between and force it out like that. Okay, Now, one of the things I would want to do is line this dimension and this dimension up, just for the aesthetics of it. And so what I would do is I would highlight this dimension, and I would pick and drag over, and then I would go down here and just park my mouse like we did before, and I would see if I can find a way to just, follow that dotted line up and snap and get those guys right in alignment like that. It just looks better when you do that. Now, the other thing that I would need to know about my part here is the overall height of the part. And so I could use this view over here and place my overall height like that. I need to know what the depth of the part would be. And again, I would want to line this up with this guy right here and pick. And if I pick on that and drag the text inside, I can there's probably enough room there. AutoCAD decides whether or not you have enough room to move stuff around. So there's an example of how I might dimension this part. Now, I'm still missing something about this part. And what it is a note telling me what the material is. If you don't tell them that, they don't know what to make it from. So that would be something you would definitely want to have a note on. And so what we usually do is we put that note to the right of our title block. And in this case, we might say that our material specification is mild steel. And so I'm going to click on model space and go back in. So actually where I have that note, here's my 3 views of the bracket, and there's that note. And I think you guys have already put that note on. So you already know what the material is. But I just wanted to use this sort of as an example. Now, what I didn't do when I place all these dimensions is something that's really important. And that is, I did not follow the guidelines for spacing or anything that are set by an outfit called the American Society of Mechanical Engineers. And we've mentioned this a couple of times. They go by ASME. And the standard for dimensioning and tolerancing is ASME Y 14.5-2009. And so in your chapter 5, you're going to read about that, and you're also going to see some other references to it in the videos and things. But I'm going to go back over here to my dimension style, and you can see right up here, I've named this dimension style ASME small radii, and I've named one ASME large radii. So that's where I'm getting ASME. It means that I've made a dimension style that complies with the ASME standard. And so I can name that anything I want, but if it is an ASME standard type dimension style, might not be a bad idea to include that in the title. So I'm going to go to my ASME small radii dimension style. Well, first let me close this and let's just go through. So let's say I want to get into my ASME Y 14.5 dimension style. First, I would come right down here and pick on my dimension style. Now, if you don't have your toolbar open, you go up here to your annotation and you pick on this down arrow. And then you would pick on this button right here. Okay, and that will open it up. You pick the dimension style that you want to make and you choose modify. And at that point, you can see all of the settings for that dimension style. And so what I'm going to pick on, there's these tabs across the top. I'm going to pick on the lines tab. And we have some settings in here for like something called baseline spacing, for extend beyond dimension line, and offset from origin. Now, extend beyond dimension line. You see this extension line that's going out right here. The distance that it extends past that arrow right there is that setting right there, 0.125. There's also, you'll see a little gap where the extension line extends out. The distance for that gap is 0.062. Now, occasionally a student will set that to 0.62, and then you wind up with a gigantic gap, and so they'll write me and say, hey, I don't know what's going on here. Be sure you put 0.062. It's not a very big gap. It's about 1/16 of an inch normally. All right. So then we pick on the symbols and arrows tab, and all of this is going to be covered in the video, and you're going to be making like 4 different dimension styles, and that's intentional. We want you to have to make the dimension styles over and over right now so that it gets into your long-term memory about how to do this. And this is also something that most of the times when a company hires a CAD person, the engineers don't know how to do all this stuff. This is what you're supposed to know as the CAD expert. How to make a dimension style is one of those. So right here you can see the size of the arrows on my dimensions are set to 0.125. And so that's the size of these arrows that we're seeing right in here. And usually, excuse me, what we want to do on that, I'm going to pick on text right here. We want our arrow size to match our text height. So if we're using 0.125 text height, that's what we'll use for our arrow sizes as well. So I'm going to go back to symbols and arrows again. Now the other day I showed you something about how do you put those automatic center marks on there using this tool right here. And one of the things, I'm going to watch what happens to this center mark when I pick on the mark button right here. You see that guy right there? That's not what you want. So under your symbols and arrows tab in the dimension style box, you want to set it to line. And when you set it to line, that's when it extends out those marks like that. Okay. So be sure that you have that. Now we're going to go to text. And so, like I said, we want this to be 0.125. Our text style, we've made a text style on this drawing where we went to Format, Text Style, and we saw there was a style there named Standard. And we went over and changed the font of the Standard style to Arial. So we want to stick with the standard text style, but that should be giving us Arial font on this. And so I graded a drawing yesterday from my Monday-Wednesday class where the student didn't have Arial set. So that was one of the things I marked up on his drawing. All right, this stuff down here's the text placement being centered, like it shows right here, centered horizontally, and reading from left to right. That's all default stuff. I don't think you'll have to mess with that. And text alignment should be horizontal. Now what that means is all your text is facing the bottom of your page. Now I'm going to click on this button just to show you what the difference is. You see when you align with the dimension line, your text aligns to the dimension line, and so it will face the bottom and it will face the right. This is what you do if you're doing the international standard, the ISO dimension standard, but we're not using that. We're using the ASME dimension standard. So we want everything to face the bottom. Okay. The Fit tab is what makes this actually a small radii style of dimension style. And so I'm going to show you something. If you have your textbook, I want you to look in chapter 5. And I'm going to show you where these settings, the difference in these settings are. If you look on page 287, so at the top of page 287, the Fit, this same tab is open right here, the Fit tab. And what those settings it shows you in the top example are for if you have a small hole or a small radius you want to dimension, you would set these, you would pick these boxes or pick these buttons right here to get that style. Okay. If you look at the example below that, look at the difference between what the leaders look like on your book on page 287. Look at the bottom example on page 287. You see the difference in the leaders, how they look between the ones at the top and the ones at the bottom? The ones at the bottom represent what I call a large radii style in the ASME. So you can see the difference between those. And so the only difference between the small radius dimension style that I made and the large radius dimension style is the settings in the Fit tab. Everything else is the same. The text height is the same. Arrowhead size is the same. Everything's the same. The only difference is the settings in the Fit tab between those two. So you can see in that section of your book, starting, like, let's say on page 284. We just take you through tab by tab of your dimension styles settings. And then we also repeat it in the video. So you're going to get plenty of exposure to what these settings do and how they affect the drawings that you're putting in. Okay. So let's go over to another tab, the primary units tab right here. And this is where you determine how many decimal places your dimensions are going to be taken to. And so I wanted to show you something on the, let me close this out. On this drawing right here, if you look at the sketch for that drawing, and let's go ahead and I'll tell you where that's located in your book. Look on page 296. This is chapter 5, page 296. Because this is your first assignment. So look at those dimensions on the sketch. And those are the same dimensions you used when you drew the front, top, and side view of this thing. There are 15 dimensions there and one note, and the note tells us what the material is. So all you need to do is get 15 dimensions onto this drawing, but look at those dimensions and think which ones are at 2 places, which ones are at 3 places, which ones are at 1 place. Well, none of them are at 1 place. The majority of them are at 2 decimal places, right? Then there's a couple that are at 3 decimal places. So what I would do if I were getting ready to dimension this guy, when I pick on my dimension style, let me pick on this, and I'm working my way through the dimension style. When I get right here to primary units, my precision I would set to 0.00. If you pick on the down arrow, you have a bunch of options here, 3 place, 4 place. But since I know most of my dimensions are going to be 2 places, that's what I'm going to set it to. So it's going to default every time I put a dimension on, it's going to go to 2 decimal places. All right. And then I'll show you how we change them to 3 places when we need to. Okay, so while you guys are looking in your book at page 296, that's going to be your first assignment, and you can see the step by step. And it says to open the bracket drawing you created in chapter 4. It says in step 2 to move the views away from each other to make room for dimensions. You may not have to do that, but you did draw your views inside that miter box, so they're kind of close together. So if you find that you need a little more room, you can always use the move command and move them a little bit apart, but you want to make sure they stay aligned with each other. But in step 3, it says to create a new layer named dimensions and set it current. And then you're going to click on the Dimension Style Manager, which is what I've been showing you here, this button right down here. Dimension Style Manager. Or, like I said, you can get to it by going to the annotation and picking on this down arrow and picking right there. All right. And then step 4A, it says create a new dimension style named ASMEY 14.5. But what I'm going to suggest is that you make one named ASMEY 14.5 or something like that and name it small radii. Okay, because then we'll set the settings for these small radius leaders, and then we'll make a second dimension style that'll be for large leaders. And then there's a table, a box right there, and it says that your setting for extend beyond dimension line should be 0.125. Your setting for offset from origins 0.062. That's that little gap I talked about. That your arrow size should be 0.125. And your center mark should be set to line and not mark. I showed you that too. That your text height should be 0.125. That your text style should be standard, but the font of the standard text style should already be set to Arial, because that's what we told you to do in chapter 4 when you set up your text style. That your precision should be set to 0.00, which it is. And then it talks about something called zero suppression, and it says suppress the leading zero. So let me show you what that means right here. So we go over here, modify, go to primary units. All right, So right down here below your precision, it talks about suppressing the leading zero. And let's look at this. There's a dimension right here that says R.80. So any dimension that's less than 1, AutoCAD will try to put a 0 in front of it unless you check this box right here. So I'm going to uncheck that box so you can see. See what it says R0.80? According to the ASME standard, we don't want that 0 there. You do that though when you're dimensioning with millimeters and it's less than 1 millimeter, but this is less than 1 inch right here. So we want to check this box right here for leading 0 and take out that leading 0. So that's what that is right there. Now this one over here, this also says leading 0, but that's a 0 on your angles, like 45 degrees. It would put a 0 in front of 45 degrees or something. So you don't want that on right there. Okay. Now, alternate units, you don't want this box checked, but if you do, what it does, it gives you, for example, you could have inches and millimeters on the same drawing, but I'm going to uncheck that box. And tolerances right here is if you turn on tolerances, this is the one that put the tolerances on that I showed you a minute ago where we had tolerances on there. We usually don't show the tolerances, but we could if we wanted to. So what we want this also to be set to none and pick OK. And then what we want to do is pick on ASME small radii and we want to set it current. And then we can close. All right. So now if we start dimensioning this, and let's put a dimension in. I'm going to use a linear dimension. And I'm going to dimension from this corner here on my right side view to this corner here, and I'm going to move out and pick like that. All right. Now that 0.75 could have been put on this view or that view, and it would have been equally good on each view. The reason for that is this vertical line right here then goes off at an angle. So I would consider this to be a profile view of that feature, that height right there. But it does the same thing over here. It goes up and then goes off at an angle. So you could put that on either view and it would be okay. But if you did this and you dimensioned it twice, I would mark that with a red pen and I would say don't repeat dimensions. Okay, so we don't need to repeat anything. You just need to put it on there one time. Here's the other thing about the ASME standard. It has rules for how far out that we place these dimensions. So if you place a dimension like really close or really far out, and you just put them all over the place, you're really not following the ASME standard. So let me tell you what the standard says. It says that the first dimension should be a minimum of 0.4 inches away from the object. Okay, so how do you know how far to come out? 0.4. Well, one way would be to do the offset command. And when it asks you for a distance, type 0.4 and press enter. And pick on this line right here and move over here to the right. So now I can see how far out 0.4 actually is. But this is really just a construction line. I've just offset that 0.4. So what I would do is pick on that dimension, and you see the blue grips. I would pick with my left button and hold down and drag that over, and when it finds the midpoint, I would pick again, and then I would press escape. And then I would go in here and carefully pick that red line and delete it out and just leave that in there. So now I know the distance from here to here is 0.4. And every time I put a dimension in, so I'm going to get rid of this guy because I don't want to repeat it. Like I'm going to put this dimension over here. I'm going to go from here to there, and I'm going to move up, and I want to put that out 0.4 as well. So the thing is, I'm just going to place it to start with. Then I'm going to pick, and I'm going to drag the text to the inside because I just prefer it to be like that. And then I could use my offset command, and it's already set to 0.4, so I just press enter, and I pick right here and pick above. Wow, I almost got that one just right. But I can pick and move down and pick like that, and then I can delete that guy out. All right. Now, that's one way to do it, to do these offsets and then put your dimensions on top of the offsets. Remember, the ASME standard says you need to be 0.4 from here to there. If you don't, I'm going to mark it up. Okay, so those would be, like -1 type mistakes. If you left this dimension off, that would be a -5 mistake. If you put this dimension to 0.750, which would change its tolerance, that would be a -5 mistake. Anything that changes design intent or anything that would keep somebody from manufacturing this is a big mistake. And so leaving a dimension off, that's a big mistake. Putting an incorrect dimension in, that's a big mistake. All right. Now, I'm going to show you another way, though, that you could put that dimension 0.4 out that is a little less involved. So let me just take this dimension out. So what I'm going to do, I'm going to pick on my linear command, and I'm going to pick here, and I'm going to pick here, and I'm going to pick just out here somewhere. And I'm going to go ahead and drag that in. Here's how you could also get it 0.4. Pick on that grip right there in the middle of the text and hold down with your left click button and drag it down to that line right there. And you could even pick and put it on that line if you want to. Then pick on it again and just hold down with your mouse and drag your mouse straight up. So I'm holding my left click button, and then I'm going to let go of that button, and I'm going to type 0.4 and press enter. So by taking this down and lining it up on that and then dragging it up 0.4, that's another way to get it out there 0.4. Okay. So that is an ASME standard, and so when I grade this, I'm going to be looking to make sure that the distance from here to there, from on that first dimension there, and the distance from here to here is the same. Now, I want to show you something. Since I've got this dimension put in right now, I want to put the overall width of the part here. So I'm going to use a different dimension this time. This tool right here, it's called baseline. Okay, I'm going to pick on baseline and look what it does. It starts where the previous dimension started. And if you go to that corner right there and pick, and then press escape to get out of it, it will automatically put that in and it spaces it for you. Now, the distance that it put in for that space was actually set in your dimension settings. I'll show you where it was. I'm going to pick on the dimension settings. Pick modify. Go over here to lines. You see this setting right here that says baseline spacing, and it's set to 0.38. The minimum for that distance between two dimensions is 0.25. So I usually go up to like 3/8 of an inch, so I set that to 0.38. But that is how far Autocad knew to space that one right there. So it was a setting. All right, so I'm going to walk through that real fast. I'm going to pick on the linear. I'm going to pick this edge, and I'm going to pick there. I'm going to move up, and I would want to go out, pick that and drag it up and go up 0.4 and enter. Press escape, pick on that and drag it in. And then I would go right here to baseline. And because I picked here first, that's where it's coming off of from my baseline. And I would just go to that corner right there and then press escape. All right. Now, let me show you something over here, how we can put this guy on. If I do a linear dimension and I go from here to there and I drag that out 0.4 and press enter. And the next dimension I need to give is 1.25 from this edge to there. The reason I know that is because when I look at the sketch, the designer gave us the height of that hole from that edge right there, 0.125. So this is a datum feature right here. We want a dimension from that edge up to there. And so here's how I would dimension that. A second ago, I picked on baseline, but now I want to pick continue. And what continue does is it just continues the dimension. It doesn't offset it like it did on the other one that I put in. So here's what I want to do. I want to come up and I want to go to the quadrant of that circle right there. So I'm going to zoom in. I'm going to pick right there on the quadrant and then press escape. So look at those two dimensions right there. These two dimensions are continuous dimensions. This guy right here, that tool, and the one over here is a baseline dimension. That would be this tool right here. All right. Now, when I dimensioned to the center of this hole, I didn't dimension to the actual center of the hole. I dimensioned to the quadrant. And because I did that, I have a gap right here, and I want that gap. I want 4 gaps around that center mark. If there aren't 4 gaps around your center marks, I'm going to mark it in red and count a point off, because I want you to know that you should have those gaps around your center marks. Here's what would happen. When I dimensioned this, if I had dimensioned to the actual center of the hole instead of the quadrant, look what happens. My dimension line, or my extension line here, it goes all the way through and goes to the center, and it takes out that gap that I had right here. So that's why when you dimension, we want you to dimension to the quadrant so that you still have this gap in here. Excuse me, instead of dimensioning to the center where you're going to lose that gap. All right. So I'm going to drag that back to the quadrant. Okay, so what you're going to be doing as your first assignment is opening up this bracket, clicking, well, you'll make a new layer named Dimensions and set it current. And then you're going to pick on this button right here and make a new dimension style with the settings that it shows on page 296. But I made a video that shows you how to place every dimension on this drawing and why I'm placing them where I'm placing them, how I'm getting my spacing. So you should watch the video really when you dimension this, and I'll cover that in Blackboard in just a second. All right, but now I want to go up to the top view and show you a couple of tricky things. Not very tricky, but okay, so we have these 2 stadiums in the top view, and we have this fillet right here. If you were trying to decide where to dimension the stadiums, would you dimension them in this view where they're hidden lines? No, of course not. And could you dimension them over here? Well, one of the rules of dimensioning is don't dimension to hidden lines, and don't dimension to the centers of hidden features. So that's the stadium is hidden in the side view, but up here we see what we would call the profile view of the stadium. This is where you want to dimension it. And so looking at on page 296 and looking at the dimensions that I need for that stadium, one of them that I need is the size of this radius right here that we put in with a fillet. And so I'm going to go up to my annotation panel and pick right here and pick radius for this tool, because I don't want a diameter, I want a radius. Then I would come right down here and pick on that fillet. And look what it does. It puts that fillet on there and it tells me R.75. Not only that, I'm going to undo a couple of times. You see this center line that's extending out right here? When you use the radius or the fillet command or the diameter command, it adds center lines to your drawing already. So we really didn't even have to put those center lines on, but you didn't know it at the time. You didn't know that the diameter symbol or the radius symbol is going to put center lines in for you. So you could even delete some of your dimensions out if you want to. The problem with a dimension, though, is it's kind of like a rectangle. It's one entity. And if you explode it, it breaks into separate parts, and even your arrowhead becomes separate. So you can't edit it very easily once you explode a dimension. So there are some offices where they won't even let you explode a dimension for that reason. All right. Now, how many of these radii do we have on here? Well, we have 2 of them. So what we need to do is come in here and double click on this guy with our left button. So we double click, and there is a cursor blinking right in front of that, and I want to type a 2 and a capital X, and I want to put a space. And then I can pick Close Text Editor right up here. So this means 2 times R.75. All right. Now, if you start thinking about that, you look down here at these two guys and you'd say, well, this is 1.25 and this one over here is 1.25. So maybe what I need to do is double click on that and also type 2x in front of this text that I have right here. Okay. Now, sometimes when you double click, your cursor will be behind it and you'll have to move. But in this case, now I've got it in front. So I'm going to type a 2 and a capital X and a space. All right. But I want to look at the diameters of these holes. Then I'm going to go back to that stadium. The diameters of those holes is 0.625. So this is a 3-place dimension. So I'm going to go up here to annotate, pick on the down arrow, and pick diameter instead of radius. I'm going to pick on that, and I'm going to move out here, and you can see it automatically puts a diameter, but it rounded it to 2 decimal places because I have my precision for my dimension style set to 2 decimal places. So what I want to do is this. I'm going to come in here and double click on that. Oh, I'm sorry. I don't need to double click on it. I just need to pick it once. And then I will need to right click my mouse. Pick right click. There we go. You pick it once and you right click and you see right here where it says precision. Go over here, go past 2 places and go to 3 places. And that's how I'm going to change because I only have two places, I think, on this where it's 3 decimal places. Everything else is 2. And the next place where it's 3 decimal places up in one of those, in the stadium. Okay, so now let's go back to the stadium. All right, so I'm going to use the radius dimension again. I'm going to pick on radius, and I'm going to pick that bottom of that arc right there, and I'm going to bring it down here and place it off my object. And that should be 3 decimal places, right? But it's only going to 2. So I want to pick it and right click, go up to precision, go over to 3 decimal places and change that to 3 decimal places. Now, how many of those do I have? Well, I have 4 of these. So I'm going to double click on that and I'm going to type 4x and a space. So now anybody making this, they know for sure that there are 4 of those and that they are R.375, and they know there's 2 of these arcs out here and they're 0.75. Another dimension related to the stadium is I need a linear dimension that goes between this quadrant and that quadrant there and then would come out here. And remember, I want to drag that out 0.4 and enter. And there would be 2x on that 2 times because there's 2 of those. All right. Now, let me show you something while I'm thinking about it. If you do this and you hand this drawing in to me like that, and you have a lowercase x and an uppercase X representing 2 times, I'm going to mark that up for just consistency. You need to be consistent. I don't care if you use lowercase. I just want you to use lowercase everywhere if that's what you're going to do. So I just recommend sticking with uppercase dimensions usually on that, because the ASME standard tells you to capitalize any word or anything that you use on a drawing anyhow. All right. Now, there's only one more thing that I want to do with this guy right here. And I want to change the style of this radius right here to the large radius style. Now, what we saw back there on the Fit tab on page 287, there's an example of what a large radius style would look like at the very bottom of page 287 on the right. Okay, so here's how you're going to change that. The book is going to, or I'm sorry, the video is going to show you how to make a small radii and a large radii. You want to set the small radii current when you're doing all your dimensions. But once you put this dimension on here, you can pick on it like that. Let me press escape. Pick it once like that. And then look up here at your ribbon and there's a tab right here that says Annotate. I'm going to click on the Annotate tab just for a second. And I'm going to look over here in this dimensions box and it says ASME small radii. So what it's telling me is that this dimension has the settings for the ASME small radii style on it. But if I pick on that down arrow, see, I made a style called large radii. Now, look what happens when I move my cursor from small radii over to large. Watch what happens on that leader. So if I pick large radii, it changes my arrow and it points out and it sweeps that entire arc. Okay, and this is actually preferred for a large radius rather than, let me go back to small radius. You see how this guy is kind of gets lost in there, and you're not sure where the radius begins at. I mean, you probably figure it out, but the preferred would be to go up here and go to the large radius style and have just that dimension coming out. Now, there might be some others we would want to do that on, but that gives you an example of the large radius style. Okay, so now I want you to go back to page 296 and look at the sketch at the top of the page. So right now I've put in I've put in 8 of those 15 dimensions that you need to go on here. And if you can see me in the box up there, I know it's kind of small probably if you're at full screen. I have my yellow Sharpie out, my highlighter rather, and what I would be doing is, as I placed each of these dimensions, I would be highlighting them in my book, because that way I can ensure that I get every one of those dimensions onto my Autocad drawing. So I would even highlight the word mild steel once I have that note on there. This is what people do in industry. They use highlighters and they go through and they highlight each thing. Because remember I said, if you leave a dimension off or you get it the wrong precision, that's your fault. You didn't do what the designer asked you to do. So when you highlight something, you want to check it and make sure it's right. And so when I highlight that note on the sketch that says 2 times diameter 0.625, that tells me that I need to make sure this says 2 times diameter 0.625 and doesn't say diameter 0.63 or something like that. So I would double click on this guy. I would type a 2x, put a space. Then I would highlight my sketch. Okay, so really this is where you need your highlighter now, because I'm going to take grades on all 4 of these projects, and these are your first grades for the course, and these are pretty sophisticated drawings by the time you get all your dimensions on there and you have your notes and everything else. But that's why we went through, and it's why I went through and I made a video for how to do all these things. There's a lot you can learn by watching those videos this week. And the assignment is to like I said, to dimension the projects from page 296 through page 299. And those should be done by a week from today at 11 o'clock. Okay. On Thursday, I'll answer any questions you guys have. But on Thursday, I want to talk about tolerancing, because that will help you really understand how to be a designer, and also it'll help you understand dimensioning. And there are a lot of schools, a lot of colleges that don't teach anything about tolerancing because they think it's too complicated. And the theory I have is that the reason beginners don't understand dimensioning is because they don't know anything about tolerancing. So what we do at ACC is we teach you about tolerancing in the first course, and then dimensioning makes sense to people once they understand tolerances. But here's the other deal. When you go to work out there in industry, because universities don't teach anything about tolerancing, most engineers, when they come out, they don't know anything about it. And so they will really appreciate having somebody from ACC on their design team who can help them with tolerancing and dimensioning and all that kind of stuff. So that makes you valuable. So it's one of the things that universities have given up, that comes to our students and makes them worth more in the marketplace, I think. So tolerancing is really important. Okay, so with that, I'm going to go look at Blackboard. All right, so hopefully you guys seeing Blackboard now. Okay, so when you go into Blackboard, I hope you're seeing Blackboard, by the way. You click on the Chapter 5 Curriculum Dimensioning Basics right here. Click on that. And it's going to take you to the Chapter 5 curriculum. And look at all these videos. Oh my God, But here's the thing. The first 3, and I broke it into 3 parts so that they wouldn't be too long. Those are the 3 you should watch right now, and just play them at double speed if you think they're going too slow. When you make a video, you kind of have to talk slowly on purpose because you don't want to screw up. But then when you play it, it seems like it's kind of running at a really slow speed. So you can always speed these things up. Then after Thursday, I'll have you watch the tolerancing videos. And that will help you become a designer. But I want to point something out to you. You see this video right here, the maximum material condition and least material condition, and this video calculating a fit between a cylinder and a hole. Those are the most watched videos on my YouTube site. Worldwide, I'll bet there's been over 100,000 views just to calculate a fit between a cylinder and a hole, because people all over the world want to know how to do that kind of stuff, And so I hope Americans are watching so we can keep these jobs here, because people in India are dang sure watching this, and other parts of the world. They want these design jobs, and and they're sitting there on their job wondering, well, how do you calculate that? And all this gets into tolerancing right in here. So these are very popular, just worldwide, in fact. And all of these videos on dimensioning and tolerancing are pretty popular because people realize how important this is out there. Okay, so I would recommend watching those first 3 videos. Then I made a PDF that's called a quick reference for mechanical dimensions. It's kind of something you can refer to. I even made some flashcards in a PDF on the do's and don'ts of dimensioning. And so, as an example, one of the don'ts of dimensioning says, don't dimension to hidden lines. Okay, that's a flashcard. So these are good for figuring out the do's and don'ts of dimensions. And remember, if you don't know that, this kind of stuff right here, you're going to be sentenced to being a drafter forever. You'll never be a designer if you can't think like this right here, the do's and don'ts of dimensions. So, like a do of dimensioning, I think it is to suppress that leading 0. Remember, I told you guys if you have a dimension less than 1 inch, you should suppress the leading 0 when you're working with inches. So that would be one of those that are on the flashcards. All right, now then it says here are your required assignments to dimension projects 5.1 through 5.4. And project 5.1, this is the assignment folder. You'll want to click on that. And that's going to take you here. And it's going to say to open the bracket project and make a dimension layer. And then it's going to say step 2, create an Autocad dimension style. Watch this video. So there's a video right there. It's going to lead you through how to make an ASME Y14.5 dimension style. So if you've got 2 monitors, you can watch the video on one and just set up your dimension style by watching on the other with AutoCAD. These are the settings that you're seeing on page 296. And then it says add dimensions to the bracket. Watch this video. So here's the video I made on dimensioning the bracket right here. And it's just going to show you how to put these 15 dimensions and this note onto the bracket drawing. All right. Now, here's what I want you to do next. Once you've dimensioned the bracket drawing, following the video and everything, I want you to print that project as a PDF and send it to me. Attach it to an email as a PDF. So I give you some help right here in step 4 about if you've had any trouble printing. Now remember, you may not see Adobe PDF when you pick on this down arrow right here, but you're going to see AutoCAD PDF. You can use AutoCAD PDF instead if you don't see Adobe PDF. So print it as a PDF, and here's something you could write down. You know, when you print a PDF, it says to give it a name. So what I would say is bracket and your name, so that when you send it to me and I get 15 projects, and actually I've got another class where I'm getting 15 projects, that I can tell your bracket from everybody else's bracket because it'll have your name in it. Okay, so be sure and put your name on the Adobe PDF or the PDF, whatever it is. And then send that to me. And here's what I'm going to do, and here's why I want you to send this to me as soon as you finish dimensioning this guy right here. When you send it to me, I'm going to look it over real quick, and if you've done your best to dimension this thing, what I'm going to do, I'm going to send you a drawing that I made back that's called a check print. And the check print is like a perfect drawing, relatively perfect anyway. It would be 100 if I were grading it. And I want you to compare the check print to what you've done. And I want you to check for things like spacing and where you place dimensions and things like that. And make your corrections, and then save your drawing again as a PDF and send it back to me, and that's the one I'm going to grade. So you dimension it first, do your best, send it to me. I'll send you a check print, and then I want you to compare and contrast. So you're actually going to do some critical thinking when you look at mine and you look at yours. This is what you're doing when you do that, is you're doing what a checker does in industry. So we're trying to train you already to be a checker, except you're checking your work against my work, right? So there's no reason why all of you shouldn't make a 95 on this drawing, you know, if you check carefully, all right? The reason why I want you to send me this one as soon as you finish it is I want to grade it and get it back to you so you don't repeat any mistakes you're making on the next 3. I want to give you feedback right away. And so if you see something you didn't understand, you know, you can talk to me about it or whatever when I send your graded one back. Okay. So I would like to have this one so I can grade it, send it back to you. You can look at the mistakes you made, and then when you go on to the next assignment, we can go back right here, go back one step. So when you come in here and you click on dimensioning the shaft guide, what you're going to see is you're going to see the video for creating an ASME metric dimensioning style, which is different than making an imperial dimension style. And then all you need to do is put these dimensions on here, and there is a video right here that you can follow when you do that. And then you'll print it, send it to me. I'll repeat the process. I'll send you a check print. You can compare it, make your changes, and send it back to me, and that's what I will grade. And we're going to do that for all 4 of these projects. So what I would try to do is get at least the bracket and the shaft guide done before Thursday. And then after Thursday and before next Tuesday, get the tool holder and tool slide dimensioned. And get all 4 of these done before next Tuesday at 11. Right? Okay, so Kyle has asked, will we be setting up a large and a small radii? Yes. And so the video is I think the video is going to show you how to set up a large and a small radii. So that's a reason to watch the video on right here on creating an ASME metric dimensioning style. And the dimension style is different for the bracket. If you click on the bracket and click on it, I think it just says creating an ASME Y14.5 dimension style. It doesn't say metric dimension style because there are differences in the ASME standard for metric drawings versus imperial drawings. Anybody else have a question they want to ask? Because I'm done. So I'll post this video in the recorded, right here, recorded class meetings session with today's date on it if you want to watch it again. But otherwise, I'm going to stay on here until 12:40. And if you're signing off, have a great day. And if you want to stick around and ask questions, you're welcome to do that. But it's time to get to work on the bracket and get it dimensioned. And so look on page 296 and look in Blackboard. You'll find everything you need. Okay? Thanks for coming today, and have a great day. And I'll hang around and talk to you if you need to. Bye.